Hey guys, welcome to the last unit. We're going to do properties of circles today for our unit on circle geometry. So everything in this unit is about circles, and we're going to do lots of things with it. Before we get into some of the good circle geometry and getting into some really good math, it's useful to go over some of the circle properties or terminology. That's going to help us with more complicated problems, especially the word problems when they don't have diagrams with them. So you're going to need to know some of these terms. So a circle is a set of points that are a fixed distance or radius from a given point or the center of a circle. And then I'm just going to go through some of the terms and tell you what each thing is. So a chord is a line that goes from one point on the circle to another point in the circle within the circle. Now we have a special chord that goes right through the middle, and that's called the diameter. But any other one, if it looks like this, is called a chord. The diameter is still a chord, it's just a special one. An arc or segment, when you have a chord, this area here that's on the inside of it is called the segment. And the distance from one side of the chord all the way over to the other side of the chord is called the arc. There's a couple different lines we can talk about. A tangent, this is the tangent, and it's called the tangent because it hits the circle at one point, and the secant goes right through. So this is the secant. There's a lot of different properties of the tangent, which we will get into in other lessons, but the tangent hits the circle at only one point. All right, a sector it's a little bit different from the segment. The segment was just using a chord, but the sector goes from the center of the circle and has the radius on two sides of it. So this is the sector. It's on the inside. This is called the sector. And then when it refers to a central angle, that's the angle that's made inside the sector. So it's the angle at the center made between the two radiuses that make up the sector. So there's our central angle right in the middle there. All right. An inscribed angle is an angle that is made with two different chords. And that inscribed angle is right here. It's that angle that's made up of those two chords that meet at one part. So this is the inscribed angle right here. Okay, so that's pretty much all the different properties or pieces of the circle and things that we can kind of measure within the circle. There's a couple different formulas I'm going to give you. First one is the length of an arc. So if we want to find out how far it is from one point on a chord to another point on a chord, we are going to use this formula. You have to have been given a central angle. This is what you need for it. You need central angle, and you need the radius. And then you can find the length of that. So basically what it's doing is looking for, if I know this and this angle, I'm going to find this distance here. What is this distance? That's what we're trying to find. So the formula for that is A equals pi over 360 times 2 pi r. All right. The area of a sector. So in this case, we need our central angle and our radius. But here we're finding what is the area. And our formula for that is pi, or theta over 360, so our central angle divided by 360 times pi r squared. And then the last thing is the area of a segment. So that's what that comes with the chord. So in this case, you're looking for this area. And the formula for that is 1/2 r squared, or your radius squared. And then this pi over 180 theta minus sine theta. Okay, where theta is the central angle and r is the radius. We're going to do a couple examples on the next page and do some of these calculations so you can kind of see how it works. All right, so here's a couple examples. We're going to express answers to the following questions to the nearest tenth of a unit. So for A, we're going to determine the length of an arc of a circle with radius 8 meters and a central angle of 110. So if I were to draw this, I would have something like this, an angle of 110, and my radius at 8 meters. And what I'm actually finding is the distance from here to here. Now, we can use our formula for the length of an arc, which was A equals pi over 360, theta over 360 times 2 pi r. So we know that r is 8 meters and theta is 110. So I'm going to put those in. 110 over 360 times 2 times pi times 8. And then all you have to do is calculate it. So 110 over 360 is 0.30555, and it repeats, times 2 times pi times 8, which is 50.2654, 8, and then to multiply those times 0.30555, and I get that the length is 15. We're going to round that, so 15.4 meters long. All right, B. A circle has radius 12 centimeters. The central angle of a sector of the circle is 52 degrees. Calculate the area of the sector. So this time we're going to do area of sector. It's 12 centimeters. Oh, I should probably draw this a little bit more realistic because it's 52 degrees. So we'll do this. 12 centimeters, 52 degrees, and we want the whole area of that. So area was theta over 360 times pi r squared. So 52 over 360 pi times 12 squared. So again, we'll calculate this. 52 divided by 360, 0.144444, and that repeats. 12 squared, 144 times pi, came to 452.389, and then just multiply. So I got 65.3, and that is centimeters, and because it's area, squared. All right, last example, we'll do a circle has radius 4 inches. Determine the area of a segment if the central area is 52 or 62.5 degrees. So in this case, we're doing a segment, which is this. We want to find this area. And they've given us the radius is 4 inches. And the angle was 62.5. So this is the last one. Area 1/2 r squared pi over 180 times theta, our central angle, minus sine of our angle. All right, let's plug in all our numbers. 1/2 4 squared pi over 180 times 62.5 minus sine of 62.5. So just make sure you follow BEDMAS and you're doing everything a little bit at a time. I'm going to do the first little section here first. 4 squared is 16, and then times 1/2 is 8. Pi divided by 180 times 62.5 is 1.09083, and then sine of 62.5 is 0.887. So I'm going to subtract those two, 1.09083 minus 7, 0.20383, and then times it by 8, and I get 1.63, and that's inches squared for that segment. So that's how you use those formulas and do some of those examples. There's a bunch of questions like that in your practice questions. It's not too difficult for today, but have fun with it because we're almost near the end. Bye, guys.